Hello. In today's video, we will talk about Kubernetes right-sizing. Right-sizing for cloud cost optimization can be one of the most effective ways to reduce the cost of your monthly cloud bill. It allows you to see where you can optimize spend and analyzes utilization and performance metrics of your infrastructure to determine whether or not they are running efficiently and what actions you should take to improve. VMware Aria Cost, powered by CloudHealth's Kubernetes right-sizing engine, makes it easier for developers to accurately estimate the resource requests required on their containers rather than a guesswork. VMware Aria Cost is now offering Kubernetes cost and usage reports built on Flex reports that are visible to users inside sub-organizational units. These multi-cloud reports help identify clusters that are under or overutilizing capacity and help optimize containers and nodes to reduce costs. Before we move on to right-sizing, let's take a look at the new Kubernetes Cost History Flex report, now available for Flex orgs. This report gives users the option to allocate costs based on actual resource usage and based on resource requests. Our new Kubernetes Cost History report replaces our classic cost history report for containers, and the key differences include how we are allocating container costs and defining what costs make up the cluster. Developers often define capacity when they use Kubernetes, like CPU and memory requests and limits for their container workloads. And that capacity usually ends up being reserved for that workload, and this in turn results in the company paying for that reserved capacity whether or not it's being used. With the new Kubernetes Cost History report, you can track actual allocation by usage, which ultimately will help you reduce overall container costs. All you need to do is install the lightweight agent, and we will start collecting data by default. There are various filters to choose from based on cluster name, namespace name, or container name. We support 5 different workload types right out of the box, as shown here. You also have the option to categorize your reports by namespace name or workload type. Let's look at an example. I'm going to select a cluster name from this graph. And this is the same as filtering to a particular cluster. And now I'm going to change the y-axis to include both options, cost allocation by requests and cost allocation by usage. This will show me the difference. Then change the graph type to bar grouped for better viewing. Now I can change my x-axis to namespace name. And say, for example, let's take this namespace dmaze. It looks like there is a significant difference in what was requested versus what is actually being used. Now I can reach out to the owner of this namespace and ask them to optimize their workloads to reduce costs. Another way of looking at it is if I want to see a list of all the containers in this namespace. Here I can now apply an additional filter and choose that particular namespace. I can categorize this chart by container name. Scrolling down, I can see the number of containers in this namespace. And it looks like web server is costing me the most, but the usage is pretty low. So this can be a good candidate to go right size. Moving on to right sizing, this is a Kubernetes right sizing dashboard similar to what we have seen for EC2 instances and VMs. At the top, you have the ability to select filters, set efficiency targets, and select a date range to generate targeted recommendations. You also have the option to group recommendations by cluster, namespace, perspective, or workload. I'm going to use filters to hone into a particular cluster. And then click on Apply. And now I can change the date range to, say, for example, 30 days. And then click on Update. The summary dashboard shows me the current CPU requested and the recommended CPU. And it also shows me the current memory and recommended memory. When it comes to right sizing, the recommendation is to right size 1852 containers, while 79 containers have no change. And below that, you'll see the recommendations table. Now I can see all the containers and also search for a particular container. So I'm going to group these recommendations by namespace. and click on Update. So here I have the recommendations group by namespace, and I am interested in this particular namespace called dmaze. And within this namespace dmaze, it looks like the most underutilized container I'm looking for is a web server. And when we expand that further, it looks like the requested CPU is about 2 cores, while only 0.13% is being used. So the recommendation is to move to a much smaller core. And the same is for memory, only 23.15% is being used. Below that, I can see the current resource metrics plotted on a graph. And it looks like the CPU is way below the efficiency target. This helps me understand the resource utilization by taking it a step further. With our request-based right-sizing engine, you can export these right-sizing recommendations to deliver to application owners. This will help lower the amount of requested capacity, which means fewer compute resources needs to be provisioned. That brings down overall cloud costs.
For more information, detailed videos, and blogs about all Aria Suite products, please visit apps-cloudmanagement.techzone.vmware.com or simply scan the QR code to learn more.